Okay, in the previous video, I introduced the forward difference, backward difference, and center difference approximations for the derivative. In this video, we'll show how these can be implemented on a spreadsheet, and we can demonstrate the difference in accuracy between these three methods. So let me open up my spreadsheet. And what I would like to do is put the three methods equations on this spreadsheet, so give me a moment. Okay, so let me copy the formulas. I can see the backward difference right here, so I'm going to copy that. Didn't catch, there we go. So that's my backward difference formula. Copy and copy here, and put it on my spreadsheet. Okay. For my forward difference, it's up a little bit. We can write it this way. Okay. Copy. Go here and put it here. Okay, so that's forward. That's backward. And let's see if we can find centered. Centered was down here, I believe. All right, here we go. We can use this here. It's slightly different notation with the xi and the xi minus 1. But xi plus 1 is x plus delta x. Xi minus 1 is x minus delta x. So we have our three values here. So let me paste that. So those are our three formulas. So this one is going to be forward. This one's backward. And then this one is centered. All right. Let's try this for a function, arbitrary function. Why don't I go ahead and do e to the x. Okay, so I'm going to specify my function, and I'll just say that my function is e to the x. And that's all. Then my function is what I'm going to call f of x in the formula. Then I want to specify the value where I'm approximating the derivative. So I want to say value of x. And let's just take x equals 0.5. All right. And we want to compare this with the exact derivative, so we'll have to put that. So f of x is going to just be the x of 0.5. And we're going to compare our results to, let's try that again, made a mistake. And the derivative at that point, which we'll compare with our estimations, is also equal to x of 0.5. Okay. So these are the equations up here. And we'll highlight those in pink. That's fine. These are the givens. And I usually put those in yellow. And let's see. Now let's go ahead and make our table. Now what I'm going to do is I'm going to approximate the derivative for several different values of delta x and see how the behavior of the approximation changes as delta x changes. So here I'm going to put another space for delta x. To put a delta in, I'm going to have to insert a special character, symbol font, and delta. I did that a little bit quickly. Let me show you again how to do that. To insert a symbol, you go to Insert, Special Character. Notice the font here says Arial. I just started typing SYM, and it comes up with symbol font, and I want this symbol, so I click OK. The problem is once you change the font, it continues to think it's the same font. I want to change this one. I want to change this X back to, well, I guess I have to go here. I want to change this back to the ordinary font, so I'm going to go up here and start typing Arial, A-R-I-A-L, and that will change me back to an X. All right. Now I want to take different values of X, so I'm going to say this is the maximum of delta X. And I have the same problem with the font. Let's fix this again. A little bit annoying, but you get what you pay for. Okay. Let's make this a little bit larger. And I'm going to start out with a maximum value of X. Let's start with a maximum value of X of 0.5. Still not quite large enough. Okay, and I want to make this yellow too, so we'll do that. All right, so now I have all of the preliminary numbers I need to compute these things. All right, so first of all, I'm going to make a column for delta X. Now notice I already have delta X here, so I'm going to copy that. And then I'm going to paste it down here. I'm going to want, when I make this computation, I'm going to need f of x minus delta x. So I'm going to put f of x minus, and I'm going to paste the delta x again there. It should still be in the memory. I'm also going to have to compute f of x plus delta x. So I'm just going to copy that and paste it there. And by the way, to copy and paste, I did that very quickly. To copy and paste, all right, I undid poorly. Let me hit Control Y to redo. To copy and paste this value, I go here. I can hit Control C, and that indicates it's a copy. Then I go to where I want to go. I hold down the Control, hit the V, and that gives me the paste. Okay. All right, so here I'll do f of x plus delta x in this column. All right, now I want the three approximations. I'm going to do forward difference. I'm going to do backward difference. And I'm going to do center difference here. So let's get those three approximations going. Forward difference, backward difference, and center difference. All right. Well, I'm going to start out with my delta x equal to the maximum value of delta x. So in this cell, I'm going to type equals 0.5. Okay. Let me make this a little bit bigger to make it easier to read. Okay. In this cell, what I want to do is find f of x minus delta x. Now we know our f is the exponential, so I have to type exp. My x is here, and my delta x is here. Now, when I fill this down, I want to keep the same x, so I'm going to fix this reference. I click in the reference, and I hold down the shift and press F4, and that fixes this reference. I will want to change the delta x as I move down, because I want to find this backward difference for different values of delta x. So that's my formula now. Hit enter. In this case, I want to do something similar. I want to take the exponential. In this case, it's going to be x plus delta x. And once again, I want to fix my reference to x. So I'm going to go here, and I'm going to hit Shift F4. We'll fix this reference. Close the parenthesis and enter. Okay. We can check that these are in fact true. F of x minus delta x, well, x minus delta x is 0. So e to the 0 is 1. X plus delta x is 1. This is e to the 1. So everything looks correct. All right. Now, we need the formula for forward difference. Forward difference formula was up here. we're going to have to take this column minus this fixed value divided by the delta x column. So let's do that. Forward difference is going to be equal to, I'll need a parenthesis, this column minus f of x is right here, and that's a fixed value, so I'm going to fix it with Shift F4, close it, didn't close correctly, close it, divide by delta x. That's my forward difference. Backward difference, it's going to be, you can see it up here, it's over a little bit. It's f of x minus delta x over delta x. Make it a little bit smaller so we can see them both at the same time. Okay, so this is going to be equal to f of x, which is over here. Can't see it too well. F of x is here. That's going to be a fixed value. Shift F4. I forgot the parenthesis, so I'll click in here to make a parenthesis. Parenthesis. Click at the end to continue typing. Minus f of x minus delta, which is here. Close the parenthesis. Divide by delta. Okay. For the center difference, I could type this formula indirectly. Another thing I could do, I remember that the center difference is the average of the forward difference and the backward difference. So here I could just type equals average of forward difference, backward difference. Okay. And we have that. All right. So we've gotten these values for one value of delta x. Let's see what we've got here. The correct value is this, 1.65, about 1.65. The forward difference was too big. The backward difference was too small. The center difference was not too bad. So we see that the idea actually works. Let's continue with different values of delta x. I'm going to fill down one row. And we have a problem. What's the problem here? Well, the problem is my delta x is not working right. The value of delta x I want here is going to be this delta x. I want to make a smaller delta x. So what I'm going to do is I'm going to take this delta x and divide by 2. That will give me a smaller delta x that I can try. And now everything is okay. Notice that now f prime here is 1.65. The center difference is real close, 1.665. Not too bad. Now I'm ready to take my formulas and fill down for several times. And to fill down, I'll just do edit, fill down. Okay. And this looks like a lot of numbers. Let's just compare the f prime exactly as 1.648. If we go over to the center difference, already here we're pretty close. These other two are just not in the running. Okay. So let's do some graphs to show what's going on here. Let me first graph the forward difference approximation. Okay. Rather than graphing the forward difference approximation, let me graph the error in the forward difference approximation. So I'm going to make all these columns skinnier so that we can have a little more room. So I'm select all those columns, right-click, format. Whoop, not format cell. Sorry, that's not what I want. Right-click, column width. Let's divide this about by 2. So I'll make it 0.39. Okay, that's fine. It doesn't leave room for a forward here. I'll just call this a C. I'll just call it like that. Okay. All right. So in this column, I'm going to do the forward error. So that's the error in the forward difference. This is the backward difference error. And then this is the center difference error. Okay. Let me just call that CD. Okay. I'll make this a little bit bigger so it's more clear. I can do that and that. Whoops, a little bit more. And here we'll just call that FW, and we'll call that BW, so we don't have a problem here. Okay, just call that ERR, that's fine. And we can make this a little bit skinnier. A little bit skinnier. The numbers are not going to matter. What's really going to show what's going on is the plot. All right, so what's the error in the forward approximation? Well, I'm not concerned about whether it's positive or negative. I'm only concerned about the sign. So I'm going to take the absolute value of the difference between the forward error here and the actual derivative, which is here. Now, when I fill down, I want to keep the same derivative. So I'm going to fix the value. The error here is going to be equal to the absolute value of the backward error here minus the same guy. And I could actually just fill right to get the third one because it's the third column here. All right. Well, we can see this error is quite a bit smaller than the other two. All right, I'm ready to fill down. Control D will fill me down. Hold down the control, hit the D, and let's plot these errors. I'll start with forward error. Select this column. Click the diagram button. I want an XY chart with lines on it. And I want the data series in columns. That's correct. Okay. Let's just, for my X values, well, let's just keep it like this for now. We won't put the X values in yet. Okay. Notice how the error decreases, and we expect that to happen. This X value here is not the delta X. It's the number of the approximate. It's the line of the approximation. But we can see that the error is going to 0, which is a good thing. Let me go ahead and change this so that the X values are equal to delta X. The way I can do that is I right-click, click with a right mouse button anywhere in the chart, and go to Data Ranges, and click on Data Series. And I'm going to change these X values and go here for the X values. The X values should be, oh, unfortunately, the graph is covering my X values, so I'm going to have to cancel that. Let's cancel that for a minute. Let's move this graph so it's not in the way. Click in the spreadsheet. Click back on the graph. Right-click, cut, and I'll move it here. Right-click, paste. It's still too big. Let's make it smaller. See if it's not letting me take that green. Oh, there we go. And let's see. There's my graph, a little bit small. We don't actually need these formulas anymore, so I'm going to cover them up because I want a bigger graph. Okay, so that's the forward error. As I said, I want to change the X values so they're delta X. So I'm going to click 2 times, left click 2 times in the graph. The border turns to gray. I right click in the graph, go to Data Ranges. I'm going to change the X values here. The range for my X values is going to be here. And everything else is okay. Let's see what the graph looks like now. All right, this looks, what's happening is that the delta X is down here. The error is up here. Maybe I should go ahead and label those axes. I think I can do that by right-clicking on the y-axis. And I'll insert axis title. So I'll call this error. I think maybe I can just type it in. I can type it in here, I think. And then this is error. No, I guess I have to do that. I have to double click in here. Let me erase this, and here's error. And then I'm also going to want a x-axis title. Insert axis title. And this is, I'll just call this, double click in there, and I'll call this delta x. And let me be more specific here. This is the error in derivative approximation. And as delta x becomes smaller, the error becomes smaller. Notice that this point, 0.5, is way out here. And as you go down in the table, the values are going down this line. Notice that it's pretty much a straight line. It's pretty much a straight line. In fact, we saw that the error, if I go back here, I didn't really talk about it, but here, if you notice this equation here, this equation indicates that the error is proportional to the size of delta x. And notice that this is for the forward difference. The same thing holds true for the backward difference. There is a difference, however, with the centered difference. In the central difference, the error is proportional to the square of delta x. Now, the square of a small number is much smaller than the number itself. So we expect much smaller error from the center difference. All right, let me go back to the other graph here. I have my forward difference in here. I want to put in my backward difference and my central difference. So I'm going to right-click in the graph area, data ranges, add another data series. This series I want to be for backward difference, so I click here. The x values are the same as before. I have to click here to enter them. Go back, select these guys. Those are my x values. My y values, select those. I have to find the column for backward difference here. That's these ones here. All right. So that should give me backward difference. I want to add also a center difference. That's the name for the center difference is here. Whoops. Let's see what happened in the chart. Okay. All right. So we got forward error, backward error. Let's look for the centered error. It's still not done, so let me right-click here. Data ranges, central difference error. X values, didn't get those yet. Got to put those in. Click here to get the values. Click here to select the region. Oops, I just want this part. For the y values, click here to get the values. This is my last one here. Okay. And okay, let's see how these compare. Look at how much smaller the error is for center difference. Also notice these are linear. This is a little bit concave, but down here it's pretty linear. But this one is concave up. It's more like a parabola. It's not very clear what the errors are doing down here because the values are so small. So what I'm going to do is I'm going to plot this on a log scale. And that will help me see more closely what values are happening down here. You can see that most of these values of delta x are very, very small. So most of the action is going on way down here. In order to get at that, I'm going to put these x and y on a log scale. So I'm going to right-click, click with the right mouse on the y-axis, format axis, logarithm scale. Okay. All right, let me do the same for x. Right-click, format axis, logarithm scale. And I'm also going to reverse direction. Okay. Now look at what's going on. In fact, the error for the forward difference and backward difference is pretty comparable. And it goes down as a straight line. If, in fact, you found the slope of this straight line, you would find that it's equal to 1. Look at this point. This point is close to 1, 1. And then this point is close to 0.0001, 0.0001. The line is going down pretty much straight. This line is also going straight. It turns out that the slope of this line is -1. The slope of this line is -2. And that's because the error is proportional to delta x squared instead of delta x for these lines. Okay, so we've finished this investigation. We've shown that the center difference is much better, much more accurate than either the forward error or the backward error. And that's it for this presentation.